What? Okay, wait. What? Plenty. Extremely cold. Use it cold every day. Okay. Consider workflow named X contains four rules. If the workflow uh, list of workflows and some part rate. Okay, so there's workflows and part rating. That's what I was so confused about. Okay, accept or reject the part. Workflow is named X. It contains four rules. The workflow says rule one: X is greater than 10, and the part of workflow. Oh, okay. This is like a regular expression thing or tree. Two, otherwise less than 20. Okay, we're building a tree here, or a graph. Otherwise, rejected, accepted. And yeah, start. Yeah, never returned. Weird metal share. Input, workflows, etc. Ultimately, three parts accepted. Adding up the X, M, A, and S rating of each accepted part gives something. Oh, okay. Okay, so we need to get the workflows as follows. So um, match word plus. Actually, no. Let's use word plus curly brace, closing curly brace, dot uh, dot B plus colon word plus uh, that's the that's that and then comma question mark uh, actually no, let's do it like this. Okay, and W, I'm already wasting time. That's fine. Wasting time is what we're here about. No val, no W. Okay, why is this? Because I didn't do the thing. Yep. That's why we test things. Okay. Now we need to. Uh, uh, is there any better way of doing it? No. Let's just push. A no, actually, hash of n equals split by commas of w. Okay, that means reading the workflows. Now, which workflow do you start? Which is the start workflow? Go through the following workflow. Okay, in is in the starting workflow. Yeah, okay, cool. Okay, so now we read that. Now we need to do following. Okay, that's okay. I just need digits, right? So jump. Okay. Uh, da, 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 um, sum split. Oh wait, no, no, no. I do need the values. I do need the values. Okay, so I need the following. Uh, Match. Okay. Dot. Um, 505 split by. Okay, that is correct. So uh, A and split by comma uh, A, my x star v equal split by equal of our A v of our x equal our v out v exit. Okay. Okay, now I need to do the processing, so W equals in. Okay, now I need to process workflow in, so while W NER and WNEA, I need to do the following. Um, H of W. Now, yeah, we copied it. So now I need to do the following. While W, I'm sorry, let's do it like that. While W, while W, what are we doing? We're doing as follows. My equals shift W. Now there is a character, etc. So uh, dot dot plus and so uh, okay, okay, so that's character operation. Da, 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 da. Okay, and now I need to do the math. So a val of dollar v of dollar c uh, op dollar n. So if it no, oh shoot, because these are d plus uh, w plus. If the rule works, then w equals hash of dollar NW, next workflow. Wait, okay, if NW equals accept, then dollar sum plus equals sum of values percent %v, and next, last, let's, if it's that, else, if it's reject, just skip it. Okay, okay, that should be it. Died at 5:21. 5:21. It did not meet the requirements. Uh, yep. Say st. Oh. Oh yes. Wait. No. W is. Oh. Yep. 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 That's correct. I need to do that. Oh, died still. Wait. Okay. That's what? Okay, how did I split those STs? Yeah, split of where did I do that? Split on comma, right? So I split it by commas. How did I get How did I get to that? Okay, let's see again. It's in LT. What does that even mean? Oh, that means unconditional. Okay, okay, okay. Okay, 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 okay. I didn't realize that was a thing. So I need to do the following. I didn't know that was a thing, so thank you for letting me know. So, okay, question mark. That means if not defined of C, or that will deal with that. Okay, that should be an answer. Let's see if it's correct. It is. Okay, great. Part 2. Then fast enough, blah, blah, blah. X mass interval ranging from 1 to a maximum 4. What? All possible, figure out which ones will be accepted. Okay. That reminds me of day 5, part 2. And only our list of workflows. How many the list outliers are no longer relevant? How many distinct combinations of one thing will be accepted? Okay, so I need to map those, and basically I need to build a tree. Yeah, so now I actually need to build the tree and do it by, yeah, by list. So okay, let's see what I want to do. So in order to do that, only need to read this. Now let's see how I want to. Well, let's figure out how I want to do this. I'm reading this. I need to start with a full and then just break apart. So okay, so that's what I'm gonna do. I wish I built that interval library. Shit. Oh, sorry. I don't know if bad words are allowed here. x from 0 to, wait, the values are from 1 to 4,000, okay? So I need to make this as a series of intervals. Yeah, let's just, oh, I wish I wrote this before. That's my starting value. Now I need to go over, how do I want to do this? Because, wait. Each, I want to memorize something. Each rule will just say if, uh, hmm, I need to do the fall. Yeah, this is like ID3, basically, right? I'm building a tree of decisions, and then need to see how many accepted. So, no, because this is a graph, but I mean, it's not guaranteed, but I mean, based on the actual input, it will always terminate, I guess. For every value, there will be. Okay, so, is this a regular? No, it's not. Okay, I need to think. I need to actually think about this for now. So we're taking the ranges and we're mapping them as follows. So once we get a check, we need to split the range into two and then say, okay, let's call, but we can call each of them on the complete range because it is, okay, how do I do this? Because again, there is a tree and I need to uh, scan the combinations. Yeah, I mean, I have the tree. The tree is represented already. Okay, then there is a decision tree. I just need to count the combinations of every the value in every uh, uh, thing. So, well, every uh, leaf will have a condition, so I can just count how many. Basically, I can build a condition for that leaf, and then tell me how many satisfy. Okay, let me think about that. So, okay. So I'm gonna do the following. I'm going to iterate, so I'm going to scan the tree. So there is gonna be a subroutine here. Okay, I'm gonna scan the tree, and what I'm going to return is, so what am my input is what state I'm in, right, and the conditions. So I have what state I'm in uh, and the list of conditions that are required. Okay, now what I need to do is as follows. I need to my W equals hash hash of st. Okay, yeah. So that's my workflow. And what I need to do now is for each of them, I need to call scan by adding that condition, except I hope that okay, I need to check if there are any of the conditions are inconsistent because then I need to immediately end. So again, it's all ending conditions. So the conditions are just minimum max. Yeah, okay. So I was right about that. That the conditions are just min max for every thing. So let's call it percentage conditions. Okay, and then what we're doing is just min-maxing, right? So, okay, let's think about it. Uh, for st uh, statement in W. So for every statement in that, I need, yeah, actually, how do I call the state? WF, let's call it WF because, yeah, we'll call this ST. Okay, or W. Okay, so now we scan that and so on. Okay, so, uh, so how do we do this? We can check. So, mhm, mhm, mhm. Okay, now I need to process these. So okay, so first of all, if not defined of C, that's an always case, then res plus equals scan of uh, NW and the same conditions as we had before, because we're not changing them. That is, and then return res, because we are done. So let's do last. Okay. Either way, this is an unconditional move. Otherwise, I need to check the specifics. So I need to check, okay, if op equals less than, then dollar cond of dollar C max equals minimum of its previous value and n. So this sets the updates the max. Actually, no, no, no. This would not work because I need. This is a complicated structure, and I can't. Okay, now let's use it like this, and that way I can access a complicated structure with no penalties. Okay, so no, I need my ncond equal declone of cond. I need a new cond. New cond equals minimum of that. If not dollar max, why dollar max? If the maximum is less than minimum, because maximum is if the maximum is less than minimum, then we don't need to consider this one next. Okay, okay, that's good. That's good. If op, oh wait, this is under if op equals less than, yeah. And the top equals greater than, it's basically the same thing. Oh, wait. Uh, I need to just check if W equals R, return 0, else if W equals A, and I need to figure out what to do there. So, map sum return and sum of map max minus min plus 1 on the percentage on cond on percentage dollar cond on values percentage dollar cond. So return sum of this map. Yeah, okay, that's counting how many are there. Now, okay, now this I need to replace it. So instead of max here, I need min. Instead of min, I need max. Instead of -1, I need +1. And this will be min. This is the same check. Actually, let's, okay. Oh, and I forgot some plus equals, obviously scan, NW, and cond, obviously, and return sum, say, scan W out cond, and then I need to actually out scan of in, and the initial hash is okay. Let's do this. I don't like the max min thing. I mean, it's fine, but I don't like it. I want it max will be of 1, replace all, and min will be of 0, replace all. Okay, thank you. That means now I can be more easily that they are. I need a hash that gov x maps to 1 to 4,000, and I actually created that hash before in a bigger, and I thought okay. Xmas, okay. ST at line 514. Hash of W. Cond at line 518. Yeah, that will be $cond. Okay, that's a very big number. Too big, in fact. So this is, I mean, it finished quickly, but I don't think it got the right answer. This is very big. So let me double check. So if you reach an accepting situation, wait, no, you don't need to do that, right? Because you need to add the opposite otherwise. Oh, 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 oh. Yeah, that's the problem. Because after you do that, you need to uh, add the opposite restriction. Because, yeah. But when you pop out, it's fine because you're getting a new one. Yeah, so, uh, hmm, uh, I see. Yeah, you need to put the opposite restriction after when you keep looping. How do I do that? I need to do that. Need to apply. Uh, okay, and I'll call it ncon just to make it easier to. Uh, and yeah, so I and then means to do this essentially. Right, okay, this is easy enough. I just need to put this here and this here. Right. And I don't want to apply it to ncond. I want to apply it to cond because this is where we're splitting to run it on ncond versus running it on cond. Way too big still. Okay. What are we doing here? I mean, it could be that this is the answer and I'm just, but let me, okay, cat to 19 simp.it. Okay, yeah, that's, wait, distinct combinations. Wait a minute. I'm not summing them, right? I need to, this is product. I'm gonna be even more. Okay. This is close to the correct number, but not quite. Is it the correct order of magnitude? No, it's one order of magnitude bigger than the number. And okay, so there's something wrong here clearly, but let's look at the output and see what's going on. So scan in. Originally all the things. So and the in is s is less than 1351. Go to px. So in s less than 1350 and between 1 and 1350 you go to px. Excellent. In px you get a is less than 2006. A is less than 2006. Excellent. And then you go to qq. Yep, that works. And QA, oh wait, scan A, you never scan A. Oh yeah, you do scan A, okay, sorry. You execute, you scan A, so this is all of those cases you will be accepting, right? Because, yeah, these are all of these cases will be accepted now. And scan R, all of those cases will be rejected. And this is fine. Scan A on this, all of those will be accepted. RFG. Okay, now this is the interesting part. RFG is it's in PX check. Okay, um, so this needs to be both A and M need restrictions. And both A and M have restrictions. Excellent. That's what it's supposed to do. And then it needs, okay, and and s less than 537. Why didn't it look at that? Oh yeah, and then GD with s less than 537. It did that, okay. And GD had an A check. Okay, both of them are R, so GD will end up in R either way. Uh, okay, okay, so this is just one combination. Okay, why is this? Okay, so the numbers. What is the maximum number? Oh, goal met. Thank you. Whatever that means. So the maximum number is only this. Clearly, I'm reaching a much higher number. Clearly, I'm double counting something. But why am I double counting something? Let's see when we scanned A. Okay, so this is all low values of Xmas, and this is another one with low values. So how did I get to scan A twice on these two? So that is the mistake. So QKQ and then okay, so and so, and the thing is, if you okay, and A and then CR. So if you got the A, once you finished, you finished, right? That's the thing. So, uh, oh, yeah, so you add that to the count, but then you need to look at the reverse condition, so, which I thought I was doing here by looking, adding the reverse condition to the thing, and then keep going. But let's, okay, this is tricky, so, okay, again. And the thing is, so scan A or low. So how did this get called? This get called from scan QKQ. QKQ, if X is less than whatever, then A. And that's fine. That's totally fine. You are called, and how did you get to QKQ? From QK, from the PX, which you got from in. Okay, now, oh, okay, now you need to assume A is greater than 2007 when you're checking the next A, which is M. And then, but instead you're looking now, scanning CRN. How did you get to CRN? CRN is if X is greater than, so CRN should have looked with X greater than that, which it is. Okay. So, wait. This is correct. These are low values of all of them. And this is an X value that does not overlap with this one. So far, so good. Okay. Now this one is low values of X and S, but high values of A and M. And the M values, this has low values of A, and this has also low values of A, and this one has high values of A. So far, but oh, is it the off by ones? Yes, it is. Because now I need they're equal, so is this off by one? I think one. Oh, okay. This 1, 5 again. So this is yeah. I got an input that's bigger than the total number, which is obviously impossible. So so I must be counting something twice, right? Because otherwise, just, okay, so must be counting something twice. Let's just only output when you accept, and let's just carefully look at these conditions. Okay, again, these have low values of every, well, no, all values of m and low values of the other. Then the second one is this completely independent? X is high, X is high. So this is independent from the previous one. So far, so good. This one, X is low, S is low, A is high, and A is high was not. Okay, that's totally fine so far. Now, M is low. That's similar to the first one. M is low. S is middly. Does that for S? M is low. Well, okay, okay. Let me add an actual check here to see if there's any. There should never be an overlap because I'm either scanning. Uh, I'm either scanning. Why is it res and not sum? Why do I? Oh my goodness. That's what I did wrong. Okay. Ah, I collected a global sum. Is this correct? Yes, that is correct. Okay. Ah, I messed up. I used a global sum variable accidentally.